Hi, good morning, good evening and good day. We have two blue squares, both with area 25 and one little red circle. Can you find the area for the red circle? Please pause the video and try it yourself. The first thing to solve the question is to find the side lengths of the square. And to find it, we can call the side lengths for little s here and here. Then we know that if we take s times s, then it will be equal to the area, 25. So s squared equals 25, and that means that s equals 5, because 5 times 5 equals 25. And then let's put some numbers in here, where this little side here equals 2, and then the side down here must be 3, of course. And the long side over here equals 5. Maybe you already know the last side in this triangle, but if you don't know, we can use the Pythagorean theorem to calculate it. And the last side, we can call it b, for instance. We can use Pythagorean theorem. We take the longest side and square it. The longest side in our case is 5. So 5 squared equals 3 squared plus b squared. And then we have 25 equals 9 plus b squared. We subtract 9 from both sides in this equation, and this will be 16 on the left hand side and b squared on the right hand side. And of course that means that b equals 4. And maybe you already knew this because the triangle 3, 4, 5 is a very famous right triangle. The most famous triangle, I think. Now it's time to draw the center point in the circle and some radiuses for the circle. And I can draw it like this. Okay, we have the center point. If we go right down here, we have one radius. If we go to the left, we have one radius. And if we go to this other blue square, we also have the radius. And we can draw straight angles like this, of course. And then now we shall only focus for the little red circle for just a moment. Hang on. We have our circle here, and let's say that we have one little point and place this point outside the circle. Maybe we can place it here, or here, and or here, or here, maybe. And let's say that we drew two tangents from the point to the circle, like this. And these two tangent lines are just touches the circle. Okay, so in this point and on this tangent point here. And then from the point outside the circle is always the same length to one tangent point as it is to the other tangent point here. And in my picture we have 209 and 209. But if I change the position of this point, we always get the same lengths to the two tangent points, no matter where I place my points. Okay, let's go back to our figure and our two squares and our little red circle. Now we know that this side right here must be exactly the same as this side over here. That means that if we have little r here to this point, and because the whole side here is 3, then the green piece must be 3 minus r. And then the other green piece must be 3 minus r too. Yes. Okay, and if we do it on this side over here, then we can put little r here. And then we have 4 minus r on this one. And then this bit will also be 4 minus r. And now we are almost there. Look at this one. 3 minus r and 4 minus r must together be equal to this side length 5. Okay, let's put in this into an equation. 3 minus r plus 4 minus r equals 5. Then we have 3 plus 4 equals 7. So 7 minus 2r equals 5. We subtract 7 from each side in this equation, like this and like this. Minus 2r equals minus 2. And then we divide both sides with this whole number minus 2. So divide by minus 2, divide by minus 2. They cancel each other out on the left, and then we have it. We have r equals 1. So then we can know the red area in this circle. Area for a circle is radius times itself and times pi. So area equals r squared pi, and then 1 squared pi. Then it equals only just pi. Okay, so the red area equals pi. Nice problem. Please give me feedback or comments or whatever stuff you want into the comments. Give me a thumbs up if you like this video. I am Jonas, a Swedish maths teacher. See you next time. And subscribe if you want to. Bye bye.